we're going to be looking at some age problems and how to create the expressions for those age problems to help you solve them a little bit easier. All right, I see a little typo from where I put this in, so let me correct this right quick for us. That should be in, not and. All right, there we go. Now we can get started. So in example 1, it says a man is 13 times as old as his son. In 10 years, he'll be 3 times as old as his son will be. How old are they now? So we're going to create a table. It always helps to create a table to illustrate what you're doing. So we have the man, and we have the son, and we have their ages now. Right, so we have the man now. We're using subscriptive variables because they seem to work the best for this. And the son now. Now in 10 years, it's going to be 10 years in the future. So we're going to add 10 years to both of these variables. So man now plus 10 and son now plus 10. And that's just going to help us when we create the expressions that we need to create to solve for their ages now. Make that a little bit more look like a N. So let's begin again with our first statement. A man is. So is, that's an equal sign. Okay. So the man is. That means the man now is 13 times as old as his son. So 13 times the son's age now. That is all ready for us for substitution. So let's look at the second statement. In 10 years, we'll be using these expressions. He'll be is a future tense of is, that's will be, so that is our equal sign. So in 10 years, he, so that we're talking about the man, so the man plus 10, that's the time frame, is equal to 3 times as old as his son will be. So his son's age at that point will be Sn plus 10. So 3 times whatever that age is. So now that we have our two expressions created, our two equations created, we can actually use the first one as a substitution value into the second one. So we'll say 13 times the son's age now plus 10. Let's go ahead and do our distribution. 3 times the son now plus 30. So we're going to subtract 10 from both sides, and we're going to subtract 3Sn from both sides, and that's going to give us, I started too far over, 10Sn, because 3Sn minus or from 13Sn leaves us 10Sn, and we subtract 10 from the 30, that gives us 20. So we have 10Sn is equal to 20. If I divide both sides by 10, the son now is equal to 2. So he's 2 years old. And I really don't need this anymore, so I'm going to put 2 here. So now if I substitute 2 for Sn here, that's going to be 13 times 2, which is going to equal 26. And we were looking for their ages now, so that is as far as I have to go. And here is my answer. Easy peasy. All right, so if you wanted to check your work, you could say plus 10, that'd be 36 and 12, and look back at your statement and say, oh, 3 times 12 is 36. So you did it right. And 13 times 2 is 26. So we solved it correctly. All right, so that is one way. Substitution, like I said, you're not learning any new steps. You're just learning a new way to create those variables and expressions that you will need for substitution and elimination problems. So let's look at example 2 for an elimination problem. All right, so now we have problem number 2 here. 5 years ago, Brenda was 4/5 as old as Leighton. It should be Leighton, sorry. I'm using the voice dictation and it doesn't always hear me exactly right. So let me put that in there correctly. I should have caught that first. So she was 4/5 as old as Leighton was 5 years ago. 10 years from now, she'll be 7/8 as old as Leighton. How old is each now? So we're dealing with two different time frames in this problem. So we have Brenda, and we have Layton. And now, let's define their ages now. So Brenda now, and Layton now. Let's 5 years ago, that's in the past. We're going to subtract 5 years. So that's going to show us BN minus 5 and LN minus 5. Then 10 years from now, that's 10 years in the future. So we're going to add 10 years. So that's going to be BN plus 10 and LN plus 10. That's going to help us create our two equations that we need. So let's look at the first statement to create our first equation. 5 years ago, Brenda was. That's our equal sign. So 5 years ago for Brenda is going to be this one. BN minus 5 equals, she was 4/5 as old as Layton was. So that's going to be 4/5 times Layton in that time period. So LN minus 5. All right, there's our first equation. Now let's look at the second statement for our second equation. 10 years from now. So that's this time period. She will be. Will be is the future form of the verb is. So that's going to be our equal sign right there. She is referring to Brenda. So that's going to be Brenda plus 10. So Brenda now plus 10 is equal to 7/8 as old as Layton. So Layton's in that same time period. LN plus 10. All right, so now we have our two equations. So what we're going to do to get rid of these denominators is we're going to multiply both sides by the denominator, and that allows us to cancel it from here. So we can say 5 times Brenda now minus 25 is equal to 4 times Layton now minus 20. Now we can move things around so that we have the variables on one side, so we can create an elimination situation. So we're going to add 25 to both sides, and we're going to subtract 4LN from both sides. That gives us 5BN minus 4LN is equal to a positive 5. Okay? So now let's look at this one, see if we can break it down. Again, we have a denominator, so we're going to multiply both sides by that denominator because it is equal. And that's going to allow us to cancel on this side. 8BN plus 80 equals 7LN plus 70 when we apply distribution. So now we're going to move things around. We're going to subtract 80 from both sides and 7LN from both sides. That's going to give me 8BN minus 7LN is equal to negative 10. Now all I need to do is multiply both of these by a coefficient that will give us some elimination function. So I'm going to use the LN. So I'm going to say this times a positive 7. That's going to give me 35 BN minus 28 LN equals 35. And I'm going to use a negative 4 here. I'm just going to go ahead and write it here. So it's going to be negative 32 BN plus 28 LN equals a positive 40. So this is going to cancel. I have 3 BN is equal to 75. Divide both sides by 3. Brenda now, her age is 25. So I don't really need these anymore. I'm going to erase that. And I know Brenda's age now is 25. And I'm going to substitute that in here. I'm just going to use this original bit before it was multiplied by the negative 4. And I'm going to say 8 times 25, that is 200. Minus 7 LN is equal to negative 10. If I subtract 200 from both sides, I get negative 7 LN is equal to negative 210. divide both sides by -7, I get that ln is equal to positive 30. So Layton's age now is 30. And that is what I was looking for to solve their ages now. All right, and that is all I have for lesson 120. You're either going to use a substitution based on how the statement is formed, or you're going to use an elimination problem like we just did. But the key factor is to write out a table of expressions using your variables so that you know what to drop in whenever you create your equations. All right, and I will see you in lesson 121.